Hello, everyone, and welcome again to the last session of Conic Sections. If you remember, we already did the circle, of course, the easiest one, and then the ellipse, and then the parabola. And today is the time to complete that with with a hyperbola. So a hyperbola, ha as you, so maybe we can construct one. So, for example, if we say um, x squared minus or plus uh, let's make that what? Y squared minus 2x plus 4y plus 1 equals 0, whatever. Oh, I'm sorry. I meant one of them is negative. You can see that if the x square and the y square have opposite signs, then this would be a hyperbola. The general shape, so when you write it again, we can do for example, since I did it, let's complete that. I just factor the negative here. So in order to complete the square here, I have to divide by 2 and square. So I get 4, and then I add 4. Here, I divide by 2, I get 1, I add 1. Notice I didn't add 1, I subtracted 1. So I'm going to subtract 1 here. So this would be y plus 2 square minus x plus 1 square equals 2. I divide by 2 both sides, so I get y plus 2 square over 2 minus x plus 1 square over 2 equals 1. So when I end up with two terms, one of them is positive and one is negative, it's telling me that it's opening towards the positive, meaning towards the y. That would look something like this. It doesn't matter which one is larger, like what we did with the ellipse, because the ellipse both were positive. So the one that was larger, uh, it means that it was the major axis, so to speak. But here it tells you whether if this was positive and that was negative, it would be opening right and left. So now let's take a couple of examples and see how we plot them. So let's make up one. So let's say x minus 2 square over 4 minus y plus 1 square over 9 equals 1. That's definitely a hyperbola opening right and left because this is positive, not because it's larger, because it's positive. So we say, okay, in this case, this is a square and that's b square. So first of all, we say the center is at 2 and negative 1. So let's draw like something generic so we see what we are talking about. The center is the middle point, exactly the point here where everything is symmetric around. Okay? And this point is 2 and negative 1. A is 2. And because it's opening right and left, I add 2. So this becomes 4 and negative 1. And that would be 0 and negative 1, right? So you add 2 and subtract 2. B is 3. B is helpful, as you will see. I'm going to go 3 up to the point 2 and 2, and 3 down to the point 2 and negative 4. You will see why that's important. Remember in the ellipse, we calculated C so that we can find the eccentricity. Remember, there is no eccentricity for the circle. It's 0. It's between 0 and 1 for the ellipse. It's exactly 1 for the parabola, and here it's greater than 1. So, because it's greater, we are adding. And we know that c squared equals a squared plus b squared. In this case, it's equal 4 plus 9. So C is root 13. Square root of 13 equals, which is roughly 36 squared is 1296. So roughly 3.6. So if you add 3.6, you get 5.6. So somewhere here, and then you subtract, you get somewhere there. These are the foci, right? And the eccentricity in this case is 3.6 over 2. It's 1.8. We said it always will be more than 1, of course, because this number will always be greater than a. We are adding a squared plus b squared. Okay. So what do we do with these? First of all, we call that the transverse axis, and the one perpendicular to it, that is the perpendicular axis. And then we are going to construct, maybe we are going to use graphing paper to make that clearer for you. And then we'll take an example for one that opens upwards. First of all, let's draw the x and y axes. So let's go, well, the center is 2 and -1. So let's go slightly higher and to the left and do, for example, this is my x. Let's go slightly to the left and say this is my y. The center is at 2 and -1. 1, 2, and -1. Here is the center. I go 2 to the right and 2 to the left to find the vertices, these two vertices. Okay. And then I'm going to go 3 up and 3 down from the center. 1, 2, 3. 1, 2, 3. So this is -4, -3, -2, -1, 1, 2. Oops. Yeah, that's 1. That's correct. That's 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5, -1, -2, -3. So you see what happened? We found the center, which is 2 and -1. We moved 2 to the right and 2 to the left because A was 2 to find the vertices. Then we are going to construct a box going from this distance is A and that distance is A, this distance is B and that distance is B. So it's a rectangle whose base is twice A and height is twice B. Why? You will see in a second. This box, when I join its diagonals, it gives me the asymptotes of the hyperbola. So that's one asymptote. And that's another asymptote of the hyperbola. And now I can draw it in a way slightly accurate. Of course, manually you cannot do it accurately, but I know now that it's opening right and left. It's asymptotic here, and then it's going to go touch this vertex and come back asymptotic with the diagonal. This one also comes where it's asymptotic here, touches, and then goes down asymptotic to these diagonals. And here we go. So I use this box just to show me how, and sometimes they ask you to find the equation of these. First of all, we know the slope in this case is y over x, so it's b over a, or it's 3/2. So m is 3/2. Also, you know that the center is a point on both, uh, basically plus or minus 3/2, because if this is 3/2, that's a negative 3/2. And then it passes through this point, for example, which is the center, which is 2 and -1. So you can say y minus -1 equals 3/2 times x minus 2, or y minus -1 equals -3/2 times x minus 2, and the rest is history. We just simplify and, write it as a y is a function of x, or you write it in standard form, ax plus by equals c, or whatever. Okay? So that's how we plot the hyperbola. Let's take another one. So let's say, let's make the y is the positive. So y plus 1 square over 16 minus x minus 3 square over 4 equals 1. So in this case, this one is opening up and down. A here is always the positive, okay? So it's not like in the ellipse or whatever. No, that's the positive. A is 4, B is 2, and C would be the square root of 20 or 2 root 5. So the eccentricity is C over A. 2 and over 4 is 1/2, and root 5, so root 5 over 2. Like we said here, the eccentricity was root 13 over 2. Okay, but this one is vertical. The center is -1 and 3. Okay, so we are going to draw it slightly down because the center is y equals 3. It's high. -1 is not a big deal, so we can do it slightly to the right if we want. Here we have to be careful because the x and the y are not are backwards, so this one would be opening up and down. -1 and 3, I'm sorry, 3 and -1. You see, 3 and -1. 1, 2, 3, -1. So here is the center. A in this case is 4, so up 4 and down 4. 1, and again, I should have drawn this line higher because it's -1, so it would be plot. We will plot it slightly below. So it's better to have the x little higher here. Okay. So let's say 1, 2, 3, 4, 5, -1, -2, -3, -4, and -5. 1, 2, 3, 4, 5, negative, negative, negative. Okay, 3 and -1. No, yeah, 3 and -1 we said is the center. Notice, we start with the x. The x is the second number, so it's 3 and -1, not -1 and 3, as many fall into that trap. We have the y before the x. So that's the center. X, A is 4. A belongs to the y, meaning I'm going to go up 4 and down 4. Well, I didn't need to erase that. And then the B is 2. So I go two to the right, two to the left. Two to the right, I come here. So, and two to the left, I am there. So now I can construct my box. Okay. Next we do, uh, let me let me do it on two steps so we can get longer line. Okay, do you see that it's opening up and down, passing through these 2 points, but are asymptotic to these two lines? So it would be more acute here. It turns quicker than the other one, right? Its eccentricity is higher than the previous example. Same thing here. You go touch here and do it like that. And again, the slope of this line, in this case, it's A over B, not B over A, because A is the vertical. So the M here, if you want to find the equations of the asymptotes, which is a very common question to ask, is plus or minus A over B. So it's plus or minus 2. We, oops, I put it backwards. I'm sorry. Oh my God. M is plus or minus 2. We pass through the center, the both asymptotes pass through the center, which is at 3 and -1. So we say y minus -1. So let's write it y plus 1 equals 2 times x minus 3, which means y equals 2x minus 6, and you subtract 1, so minus 7, or y plus 1 equals -2x minus 3, so y equals -2x plus 6 minus 1, so plus 5. So that these are the two equations, or the equations of the two asymptotes. Here are the vertices. If they ask you to show the foci, we know that it's 2 root 5, so roughly 4.6 something away from here. So it's at 3.6 something, and at negative, wait a second, we said no, no, that's incorrect. Yeah, we added 4.6, so negative 5.6 somewhere here. So we can find the two foci if you wish. We have the centers, the center, we have the two vertices, and we have the asymptote, so it's very easy to plot. That's pretty much a more involved or complicated conic section of the four, but as you can see, it's not hard. It's really just identify A and B. You have the equations A squared plus B squared equals C squared for that. A equals C for the parabola, and C squared equals A squared minus B squared for the ellipse. And of course, there is no eccentricity at all because C is 0 for a circle. I hope that was clear. I think now we completed all the conic sections. So again, as usual, I ask you if you have any questions to let me know in the comment section, and I will get back to you as soon as I can. Thanks, and have a great day.